Good morning, dear students. I am Dr. Srinivas Pathani, Professor of Chemistry in St. Peter's Engineering College. So, in the last video, we have discussed synthetic petrol. That was we have completed. So, synthetic petrol used in the laboratory, especially from methane or coal gas or biogas. Okay, we will get the crude oil, that is saturated and unsaturated hydrocarbons. Okay, that was we have completed. So today we are going to discuss about what topic? Knocking. So knocking is very important. So what is knocking? Okay, what is the topic? Knocking. Knocking. So general definition I will tell you. So simple thing. Premature and instantaneous ignition of petrol. Instantaneous ignition petrol. If you have to kick it, the ignition will start. So what? Air mixture, that fuel and air mixture in a petrol engine leading to the produce of explosive violence is known as knocking. What is that? Air fuel in a petrol engine leading to production of explosive violence is known as knocking. The knocking. So that is general thing, but actually I will explain you. In an internal combustion engine, a mixture of gasoline vapor and the air is used as a fuel. We have taken a petrol from petrol pump. Okay, so the air is inside. Air plus gasoline mean petrol act as a fuel, both. Only petrol is there. There is no oxygen. There is no use. Without oxygen, the petrol will not burn. Okay, so always we have to use the petrol as well as oxygen. After the initiation of the combustion reaction, it burn. Combustion reaction, it burn in the presence of oxygen. Petrol burn in presence of oxygen. Hydrocarbons burn in presence of oxygen to give the energy, that is the carbon dioxide as a pollutant, and water will come. So when combustion takes place by a spark in the cylinder, the flame should spread rapidly and smoothly through the gases mixture. Thereby the expanding gas drive the piston down the cylinder. That will happen in the engine. So the ratio of the gases volume in the cylinder. So what are the ratios? The ratio of the gases volume in the cylinder at the end of the suction stroke to the volume. What is that? The ratio of the gases volume in the cylinder at the end of the suction stroke to the volume at the end of compression. Compression is nothing but what? Stroke the piston. Compression is what? Stroke the piston. End of compression. That is end of the compression. Starting suction and end of compression. That is known as the compression ratio. Compression ratio. What is meant by compression ratio? The ratio of the gases volume in the cylinder at the end of the suction stroke to the volume at the end of compression is known as compression ratio. The efficiency of internal combustion engine increase with the compression ratio. The efficiency of engine, that will always increases the combustion ratio. If combustion ratio increases, the efficiency of engine increases. which is depend on the nature of the constituent present in the gasoline used. In certain combustion, certain circumstances, especially due to the presence of some constituents in the gasolines used, what type of gasolines used, the rate of oxidation becomes so great. Oxidation means there is a burning, that is called oxidation, is nothing but combustion. That oxidation becomes so great, combustion so great, that the last portion of the fuel mixture gets ignited instantaneously. The last petrol drop will run the vehicle because of that much of instantaneously producing explosive violence is known as knocking. What is the rate of oxidation becomes so great that the last portion of the fuel air mixture gets ignited. If one liter we have to using starting, and that last one drop also ignited instantaneously and producing explosive violence is known as knocking. The knocking results in loss of efficiency. Knocking results the loss of efficiency. So what are some effects of knocking we can see? What are the effects? What are the effects are there? Carbon deposits on liners and combustion chambers. Carbon, because the hydrocarbons we are used. The hydrocarbons mean hydrocarbons mean, example are what? Petrol is saturated and unsaturated. This both so gives the carbon dioxide and water and energy. So in this what carbon and hydrogen is there? Higher alkanes, for example CH3, CH2, 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 CH. This the petrol. For example, this is burning. So what will give? Carbon dioxide and what? Some carbon is there. Some carbon is deposited on the liners and combustion chamber. Mechanical damage, the carbon formation, mechanical damage. Sometimes the vehicle will slow down. Increase in heat transfer, noise and roughness, the decrease in power output of efficiency and pre-ignitions. So this will affect by knocking. The knocking, effects of knocking. So these are the some effects. And the knocking can be controlled. How can you control the knocking? Or even stopped by the methods. What are the methods? So increasing engine RPM. What is the RPM? RPM, increasing the RPM. Reducing the pressure in the inlet manifold by throttling. Simply reducing the pressure in the inlet and retorting spark, making the ratio or rich preferable. And water injection increases the delay period as well as reduce the flame temperature. We can reduce the flame temperature. And use of octane fuel can eliminate the knocking. Octane fuel eliminate the knocking. High octane fuels are obtained by adding additives known as dopes like tetraethyl, benzoyl, xylene to petrol. So when we have to use the petrol, so we have to add the xylene, benzoyl or tetraethyl. So we are using the tetraethyl. We can reduce the knockings. So these are the some reducing and effects of the knocking. And chemical structure and knocking. So what is the chemical structure of knocking and knocking? So the tendency of fuel constituent to knocking. So how they are in the order, you can see that one. The order of the knocking. Straight chain paraffins, we get the straight chain paraffins. Straight chain paraffins are greater than the branched chain paraffin. Is greater than the branched chain paraffins. Is greater than the olefins. Olefins mean, what is meant by olefins? Ethylene double bond. Double bond, C double bond C. This is called the olefins. Then is greater than the cycloparaffins. Cycloparaffins. Cycloparaffins mean naphthalene aromatic compounds that are is greater than the aromatic compounds. Straight chain paraffins is greater than the branched chain paraffins and greater than the olefins, then greater than the cycloparaffins, then aromatic compounds. That knocking order. This is the knocking order. Knocking order. The olefins of the same carbon chain length possess a better anti-knock properties. Thus, what? Olefins of the same carbon chain length possess better anti-knock properties than the corresponding paraffins. Mean that is branched chain paraffins, straight line chain paraffins better. This one is better because the olefins. Okay, and now see the what is octane number and cetane number. We will set the octane number and cetane number. Octane number and cetane number. So these will also we will discuss in the knocking. That is important. So what is meant by octane number? The knocking characteristics of fuel can be easily expressed by octane number. What is that? The knocking characteristics of fuel we can express by using the octane number. The anti-knocking value of anheptane. The anti-knocking knocking of anheptane taken as a 0. We can take as the zero value. The anti-knocking value of anheptane is taken as 0 because anheptane knocks very badly. Because the bad knocking value. Very badly. Whereas the anti-knocking value of isooctane, we can say isooctane, approximately taken as 100. You can this value is the 100 because isooctane knocks very little, very good or little. It knocks little long, very high value. The octane number is the percentage of isooctane in a mixture of anheptane to match the anti-knocking characteristics of the fuel. In this way, an 80 octane fuel is one which has same combustion characteristics, same combustion as an 80:20 mixture in isooctane and anheptane. We can take the both 80:20. So same characteristics will come. 80 octane mean that fuel, we can say the same combustion characteristics as an 80 to 20 mixture in isooctane and n-octane. So both we have to take isooctane as plus n-octane. So 80%, 20%. It is same act as like this one, 100. So 80 is kind of mixture. We can take 80% this one and 20% this one. The value is same. So like that, the octane number of fuels. I mean, for example, so gasoline with an octane rating has 135 used for aviation purpose, because the octane number. So 135 octane number. So this standard, the 135. You have to use the aviation purpose. You have to use this, the aviation purpose. The octane number of pure fuels can be raised by the addition of extremely poisonous materials like tetraethylene lead and diethyl telluride. Also, we have to use that one. So, can you know that the structure of octane and n-octane? N-octane is the simple. So, what is that? Just I am writing here. N-octane. N-octane means CH3, CH2, 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 1, 2, 3, 4, 5, 6 and 7. This is the what? N-octane. N-octane. So its knocking value is, octane number is 0. Its octane number is 0. Mean, so bad fuel, we can say it's a bad fuel. Whereas isooctane mean that is this one, CH3, 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 CH2, CH3. So 1, 2, 3, 4, 5, 6, 7, 8. In this one more CH2. 8. CH2, CH3. Mean 1, 2, 2, 3, 2, 2, 1, 2, 3, 4, and 4 trimethyl 1, 2, 3, 4, 5 pentane. So this is the trimethyl pentane. So its octane number is the 100. Octane number is 100. So it's a good fuel. We can say good fuel. Mean branched chain. It's a branched paraffins. So it's a straight line paraffin. It's a branched paraffin. So it is called the octane. 1, 2, 3, 4, 5, 6, 7, 8. Octane means that 8 carbons are there. So what is the chemical structure? 2, 2, and the position of the carbon containing 2 methyl groups and the 4th carbon containing the 1 methyl. So we can say 2, 2, 4 trimethyl pentane. So octane number is 100. This is act as a good fuel. Okay, so this is a good fuel. So when a mixture of 80% to 20%, it is act as same characteristic like this compound. It is also. And this is about the structure of octane numbers and octanes. So one more thing is the octane number of pure fuel can be raised by the addition of extremely poisonous material like tetraethylene lead. Tetraethyl lead. C2H4 tetraethylene lead. This is the tetraethylene lead. Or diethyl telluride. We can say telluride. Diethyl telluride. So this is also became used by reducing them. These are the poisonous, the knocking, the octane number pure fuels can be raised. Mean you have to raise it. So if for example, N-octane is a pure fuel, so octane number is 0. So we have to raise to this much 80 to 80 or 90, because when addition of this tetraethyl lead and diethyl tellurium. So this type of you can use. So okay, now lead petrol. Lead petrol. What is the structure of the lead petrol? Tetraethyl lead. So this is the tetraethyl lead. This means lead. This means what? CH2, CH3, like this. CH2, CH3, CH2, CH3, like this. So 1, 2, 3, 4. Tetraethyl lead. So when tetraethyl lead is added to petrol, we can say to petrol, so is called the lead petrol. What is that? The variety of petrol in which the tetraethyl lead is added to petrol, it is lead petrol. You can say lead petrol. Okay, now octane rating. So what is meant by octane rating? It has been found that N-octane knocks very badly, already we know. Hence its anti-knock value as arbitrary been given to 0, already we know, and N-octane value is 0. On the other hand, iso-octanes, that is 2:4 trimethyl, mean 2, 4 trimethyl pentane, that is the isooctane. So its value is how much? Its value is 100. Its knocking value is 100. Thus, octane number rating of gasoline or any other internal consumption engine fuel is the percentage of octane mixture of isooctane and N-octane which matches the fuel under test. What is that? So that compulsory match the N-octane and isooctane. So should be matched this one. Any internal combustion value, mean knocking. So knocking characteristics. So how can you knocking? In this way, an 80 octane fuel, mean 80:20. We can say 80:20. 80% this, 20% this. So 80:20. 80:20. 80:20. A mixture of isopentane, isooctane and N-octane, a mixture, that is 80:20. Mean an 80 octane fuel is one which has the same combustion characteristic as an 80:20 mixture. So mean this is the function, the mixture is function like a pure isooctane. So 20% of N-octane, 80% of isooctane we can add. So that mixture gives the result that is equal to isooctane value, mean 100 value, mean it will be good fuel. Okay. So what are the advantages we can see? Advantages. Usually petrol with low octane number is not good, we know that. The quality of petrol is not good. Low octane number, if N-octane is 0, it's not good, it's a bad one. So it often knocks, mean the produce use noise due to the improper combustion. Sound will come if you use a low quality, for example, a diesel and kerosene oil. Somebody use the kerosene oil, lot of smoke will come. So in the villages or somewhere, I have seen just they are, instead of diesel, they are using the kerosene oil. So the different sound will come, the smoke will come, mean that the quality of the combustion quality, the octane number, we can say octane number of kerosene oil is 0. It's a bad value. Bad. The petrol car is a good, because the octane number is very high, nearer to the 100. Octane number should be 100. So that is the difference. So that are the advantage of the octane number. So mean bad quality will come. As a result, what happened? As a result of knocking, the petrol is wasted. The sound will come and smoke will come, improper combustion, the wasted of petrol. So that immediately the mileage will reduce the mileage. For example, per liter is give the 80 km per liter. Instead of that, per liter 20 km will come. Mean improper combustion of the petrol, improper quality, the use noise, dug 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 sound, that will produce the sound. So because the reason, the quality of petrol, the octane number is not 100, that is nearer to the 0, not nearer to the 100. Okay, that is the advantage. That is the reason we have to add the knocking agent. So knocking agent are what? This one, tetraethyl lead, and some more knocking agents also there. Mean diethyl tellurium. When tetraethyl lead is added, it prevents the knocking sound, that knocking improper. So thereby saves money and energy. We can save the energy as well as money. So usually how much tetraethyl lead is added to the petrol, that is important for general knowledge. 1 to 1.5. 1 to 1.5, this one tetraethyl lead added to petrol. Per liter of petrol. 1 per liter of petrol. 1 to 1.5 tetraethyl ml of tetraethyl lead. So to added per liter of petrol. Per liter of petrol. So 1 liter of petrol we have to take. In this, how much of tetraethyl lead is there? Just 1 to 1.5 ml. So, but it is a bad, tetraethyl lead is a very bad gas. Okay? The mechanism of action is how? Mechanism, we can see that. First, tetraethyl lead will transfer into finely powdered, finely divided particles, small particles. We can take this one finely powdered. So this will be mixed into the petrol, okay, which looks like a cloud. This takes place in the cylinder, I mean the gas cylinders, petroleum cylinders. Then the lead oxide particles react with the finely powdered particles. Tetraethyl lead. So I will draw it. Tetraethyl lead so this tetraethyl lead added to the, transferred to the finely divided particles of lead oxide, which looks like a cloud, tetraethyl lead and lead oxide. This takes place in a cylinder. Then the lead oxide particles react with the hydrocarbon peroxide molecules. What? So this mixture we have to add to the petrol, hydrocarbon molecules, peroxide molecules. Mean that lead oxide react with the hydrocarbons, so hydrocarbon peroxide molecules form. So immediately what will form? Peroxide molecules. Peroxide. So lead peroxide molecules will form. When tetraethyl lead mixed with the fine particles of lead, the cloud formation takes place. This one add to the hydrocarbons, mean petrol. So then what happens? The formation of peroxide formation takes place. This is the mechanism. This formation of peroxide. So thus slowing down the oxidation process. What happened? That immediately the oxidation process and prevent the knocking, prevent the early knocking. The either knocking may be stopped or greatly reduced. So knocking, this happened what? Knocking will stop or reduced if used. That is the reason that use first tetraethyl lead added to the fine particle of lead oxide, then to the petrol. So what happened? Mechanism will start peroxide formation. This formation immediately stop the knocking or reduce the knocking. So mean that vehicle will go smoothly and mileage will give very high. So that's the reason we have to use the tetraethyl lead. So what are the advantages? We can say advantages. So when deposits of lead oxides are harmful to engine, we can say disadvantages, not advantages. So what are the disadvantages of this one? So disadvantages mean deposit of lead oxides are harmful to the engine. So how? Lead oxide must be eliminated from the engine, otherwise it will be very dangerous, lead oxides. So how to eliminate the lead oxide? For this purpose, a little amount of ethyl bromide we have to use. Little amount of ethyl bromide. So this lead oxide. So lead oxide plus ethyl bromide. So for this purpose, a little amount of ethylene dibromide or ethyl bromide. Ethylene, or sorry, we can say dibromoethane. We can say dibromoethane or ethylene dibromoethane. So dibromoethane ethyl dibromide is added to the petrol. In the petrol, how many particles are there? In the petrol, diethyl bromide is there, lead oxide is there, TL is there, then the peroxide formation takes place. So it converts the harmful lead oxide, the ethyl bromide, convert the lead oxide to volatile lead bromide. Volatile lead bromide. So main lead bromide. Volatile lead bromide. Volatile lead bromide will formation takes place. So volatile lead bromide. So this will be, so lead will evaporated and these hydrocarbons will mix into the petrol. So this is the process of mechanism. So what will compound? So ethylene formation takes place. Ethylene formation takes place. Ethylene. When lead mixed to the ethyl dibromide and to form the lead bromide and ethylene will come. Okay, this is the lead oxide ones. What are the disadvantages? So disadvantage mean that it's an harmful gas. It is a harmful gas, harmful to the engine. So that is the reason you have to eliminate. How to eliminate? When diethyl bromide mixed with the lead oxide to form the lead bromide will formation takes place and ethylene will takes place. Okay, so this is about the tetraethyl lead main, that is elimination of lead from the petrol. Okay, that is the disadvantages. And finally, cetane number or cetane number. So we are seeing the octane number. Now cetane number or cetane number. We can say cetane number or cetane number. So pronunciation, two types of pronunciations are there. So cetane number and octane number. Octane number you have to use it for petrol. Now cetane number is defined as the percentage of hexadecane. Percentage of hexadecane mean N-cetane. N-cetane. So it is called the hexadecane. Hexadecane. Hexadecane is called what? Percentage of hexadecane is called what? N-cetane. So N-hexadecane present in a mixture of hexadecane and 2-methyl naphthalene. So what is the cetane? Mean hexadecane plus 2-methyl naphthalene. So 2-methyl naphthalene. 2-methyl naphthalene and hexadecane. Hexadecane and 2-methyl naphthalene. It's a mixture of cetane number is the percentage of hexadecane present in the mixture of what? Hexadecane and 2-methyl naphthalene. 2-methyl naphthalene. So which has same ignition characteristics of diesel fuel. So that is the same thing. It is the characteristics of the diesel fuel. Diesel fuel. Same characteristics of diesel fuel. Diesel fuel. So same ignition characteristics. This fuel is the ignition characteristics, and this one also, that mixture also means cetane number is the same characteristic. So diesel fuel with cetane number is almost how much? 70 to 80 are used. That number, cetane number is the 70 to 80. 70 to 80 are used. That is the what? Hexadecane as well as 2-methyl naphthalene. Okay, the knocking tendency of diesel fuel is expressed in terms of cetane number. The knocking for diesel fuel. So octane number for expression for petrol fuel. So now cetane number the knocking tendency of diesel fuel is expressed in terms of cetane number. Diesel engine works on the principle of compression ignition. So cetane or hexadecane is saturated hydrocarbon. So what is that? Saturated hydrocarbon. Its cetane number is arbitrarily fixed as 100. We can say 100. Methyl naphthalene is an aromatic hydrocarbon. Its cetane number is almost 0. So methyl naphthalene cetane number is simple. This one is what? How much? It is 0. And hexadecane, it is the 100. So in the petrol we have seen the isooctane is 100, N-heptane is the 0. Same yearly, N-hexane is the 100 and 2-methyl naphthalene is the 0. This one. Understand? So that is the different this one. So this is about the, so here we have to see the octane number for petrol and cetane number for diesel. So here in the petrol we have seen the N-heptane and isooctane, that is the 80:20. Here we have the 70 to 80. 70 to 80 we have to take in. 80% is this one and 70% is. So because the 2-methyl naphthalene is the 0 number, cetane number 0 and hexadecane number is the 100. So this is the diesel for using cetane number used for the diesel fuel ignition and octane number used for the petrol ignition. So this is about the knocking story. Okay, thank you very much.